Hi, hello everyone. We're gonna resume our class here, and some of you already turned in the assignments that is due tomorrow. I really appreciate that. I think it's a kind of interesting class, so hopefully you like it. Anyway, in the timer, in the book, we have this TON, TOF. We know if you have a switch, have a switch, let's say this is a switch that's gonna turn the timer on, TON, and certainly you have a timer name. And now the book has a time base, has this variable over there, and then preset and accumulated or somehow like that, and EN. The book also has a DN, and then those are all given to you. By the way, the newest version of the software, this time base is taken out, so you won't see the time base. Kind of unfortunate we don't have the machine, we don't have the software. We're just talking on the paper, on piece of paper. And the time base is set to a millisecond. So it's kind of unfortunate. But in your assignment, if you set the time base to 1 second or whatever time base, that's fine with me. I can still work with that. Okay, and there's another timer that I haven't talked about is RTO. RTO is called retentive timer. And this one here is just not a whole lot of use of this timer, because you see any of this timer's function, RTO function, can be realized by TON and TOF. But let's take a look at this RTO here. Let's say if we have a switch, again, to turn this RTO on, just like TON and TOF, it has a timer name. You can give a timer name. Let's say I'm gonna give this name. Let's say I say RTO. You can give it any name. RTO. Let's say RTO3. I just gave any name. So it's a little bit different from the book. The book gave you some format like T4 column 1, T4 column 2. That's the old version of the software. The newer version you can give any name. Okay, that's any name. And still, it has a time base. The newer version taken time base out, and it has a preset. Let's say preset. Let's say if I set a preset to 1000, that's equal to 1 second. Then it has a cum and 0 here, and it also has a EN and a DN. Those are given by the software here, Now, this RTO, once the switch is turned on, this cum will start, the number of the cum will start to increase all the time. So, when this cum, just like TON, TOF, when a cum reaches preset, then this DN bit, or address of this RTO3 DN will become true. It becomes 1. Okay, less than that, that's less. And then TT certainly is just the RTO3, RTO EN, and RTO3, I choose this name, RTO3, can be any name. TT will be true as long as the switch is true. Okay, as long as the switch is true. And TT is as long as preset 0 accum and preset that is true. Thus TT will be true. TT is equal to true. Here, equal to 1. And this one here, EN, as long as switch is on, this EN will be on. Okay, so what's the difference between RTO and the TON? The difference is that the accum will keep accumulating, even when you turn the switch off. Okay, now TON, the accum will keep accumulating, will keep increase, number will keep increase. But TON, when the switch turned off, the accum will automatically set to 0. Automatically set to 0 here. RTO, when your switch turned off, the accum will not set back to 0. Will not set back to 0. So this is the only difference between a TON and the RTO. You have to manually set this accum to 0. So there's a function called a reset. Okay, there's reset. You have to manually reset. Reset this accum to 0. Okay, so that's how we do it. Let's say if I have another switch, or you can use this RTO bit. Let's say if this DN is true, I'm going to set this to 0 here. So RTO3 DN, when this DN is true, I'm going to reset this RTO3. RTO3. I'm going to reset this. I'm going to use this function, RES function here. Reset that. I'm going to reset that. And this way, when this DN is true, becomes true, I will reset this accum to 0. Accum to 0. That's how RTO works. And now, next lecture, I'll show you one function that we can use the RTO to implement an application. I'll show you that. Okay, and this week I'm gonna give you assignment. That's gonna be on page 155, number 11. Page 155, number 11 here. It says write a program for an anti-tie-down circuit that will disallow a punch press solenoid from operating unless both hands are on two palm start button. Both buttons must be pressed at the same time within 0.5 seconds. The circuit will not allow the operator to tie down one of the buttons to operate the press, just one button. Okay, so there's a hint over there. And let's make this due next Wednesday too. Okay, Wednesday next week, not tomorrow. Wednesday next week. Okay, here is a problem. We have a machine. Let's say if we have a machine, and this machine, it has two start button, start. And some of those machines are very dangerous. Okay, if you push start, it will go down like that. It will go down. Now, human beings has a tendency, let's say if you see a piece of debris here or something like that, you naturally want to raise your hand over there, make your hand reach there to pick up the debris, but this machine moves fast. And a lot of accident happens if your hand is free, the accident could happen. So we want to both hands push this two start button within 0.5 seconds to activate this machine, to activate this machine. And so your hands, both hands, has to be on the start button for the machine to activate. Now if you take one hand out, then the machine will stop. Okay, then the machine will stop. And certainly, we are getting very smart. You would think, hey, I use a duct tape and tape this one here. Now, I can only use one hand to operate that, right? And so this program, the so-called anti-tie-down, and is to prevent you doing that. You cannot tape it. If you tape it, still that's not going to operate. So give it a try. That's really interesting, really fun, and it's a simple program, but you got to think it somehow. Sometimes really hard to find a solution. Okay, if you have any questions, email me. Thank you.